All right, everybody. Sorry I'm not back yet. Hopefully tomorrow, all going well. Again, I feel well right now, but I have to have a negative COVID test before I can come back with you guys. So I want to make sure that we go over the 3 worksheets that you did over the last few days in the hopes that then when I am back, you can ask any questions, go over anything, but hopefully with the simple stuff of just wanting to know, did I do it right? We can have that cleared up before I come back. So here we go. Let's take a look at the Unit 9 Worksheet 2. Again, it says Unit 9 because this is straight out of Math 3 instead of the foundations stuff. It's the same material, but just one of the introductory worksheets that we work through with them. If you don't have a copy of this, or if you don't have a copy of any of the 3 worksheets, check with the sub. Hopefully there's extra copies on my desk still from last week. If not, again, you can do this on a blank piece of paper. If you're at home, again, you should have been able to see these on Google Classroom. You can print them out or just do it on a blank piece of paper. So just going through quickly, one by one, if I look at number 1, log base 5 of 25. When we first looked at this, we talked about it being the what power function, saying what power of 5 gives me 25. And so in this case, it's 2. That is my answer. The 2 is my answer, but if I wanted to check it, I could say, okay, 5 squared, that makes 25. That's what I want. So going through to the next one, log base 3 of 81. Okay, 3 to what power makes 81? Well, again, if you're not sure, just start multiplying 3's together. 3 times 3 would be 9, times another 3 would be 27. And that 4th 3 is what gets us to 81. So again, the answer is 4 there. The decimals. If you got thrown off by the decimals, don't be too worried about it. Yeah, this one, log base 4 of 0.25. If you got stuck on this one, again, don't be too worried about it. But the key to this one was seeing that 0.25 is actually 1/4. And so that just means I'm raising the base 4 to the -1 power. And again, we'll do more like that. That one's a tricky one. Next one's a little bit more obvious. We've got 7 to what power makes 49? Well, 7 squared makes 49. But if I want it to be 1/that, I need it to be negative. That, again, the negative exponent is what gives us 1/our answer, or flips our answer upside down, makes it the reciprocal. So coming down here then, number 5, log base 2 of 1/8. Log base 2 of 1/8. We're looking, okay, 2 to what power makes 8? Well, that's 2 to the 3rd power. And then if I need that to actually be 1/8 instead of just 8, that's where we put that negative here. Okay, number 6 is another one where you may have gotten stuck. The idea here is you need to know that the square root symbol means 1/2 as an exponent. This is 1/2. Again, the 2 on the bottom is the type of root here. But this is a square root, so it's 1/2. If that one and the next one threw you off, don't be too worried about those. We'll talk more about those in the coming days as we work through. But again, a square root is a 1/2 exponent. So 3 to what power makes the cube root of 3? Well, it's 1/2. The next one is the exact same idea, except it's a cube root. So it's 1/3, the 1/3 power. Number 8, this one is the same idea as the last two, and there's a couple ways that you can get this. If I want to go for log base 9 of 3, I know what log base 3 of 9 is. That's 2. 3 to what power makes 9? It's 2. If those numbers are switched, your answer is the reciprocal. Again, I'm worried that the videos that I shared with you guys may not have talked too much about that. If that threw you off, again, this is another one it's one of the edge cases. It's not the key thing that I wanted you guys to take away from it, but it is something that we should know. And so here, this one is actually the same as number 6 there. It's going to be 1/2. because really, if I look back up here, the square root of 9 makes 3, and the square root is 1/2 as an exponent. Get the same thing happening with number 9 here. Log base 2 of 8. 2 to what power makes 8? Well, 2 to the 3rd power. So this one, they've been switched. So this is 1/3. Or the cube root of 8 makes 2. Some of you had seen, we saw ones like this when I was with you guys last week on Tuesday. And a couple of you had picked up on the fact that anything to the 0 power is 1. And so anytime we've got a 1 inside here, it does not matter what kind of log it is. The answer is just going to be 0. So we have a couple of those showing up every once in a while. So we want to watch for those. Number 11, log of 1/2 to the 1/8. 1/2 to what power makes 1/8? The 1's not changing. So really, I just need to focus on the 2. 2 to what power makes 8? Oh, well, 2 to the 3rd power makes 8. And yes, in fact, if I do 1/2 to the 3rd power, 1/2 times 1/2 times 1/2 does make 1/8. And so my answer is just 3. Now we're getting into more complicated ones. And again, for a lot of these, the harder ones, I'm not worried if you had difficulty with these. These were some of the ones that I wanted you to see and try out. Again, if I had been there, we would have worked through them together. But this one is kind of a combination of what we were seeing before. In order to go from 9 to 3, I need it to be the square root of 9, or the 1/2 exponent. Just like, again, if I was doing log base 3 of 9, it would have been 2. So here I switch those. It needs to be 1/2, the reciprocal. But then in order to make the answer the reciprocal, flipped upside down, that was a negative. This is probably one of the hardest things about logs, is that we have those 2 separate rules that deal with reciprocals. One where if I've swapped the base of the log and what's inside, my answer is the reciprocal of what it would have been otherwise. Or we also have, if my answer is supposed to be a reciprocal, then I need a negative in my answer for what the actual log reduces to. So this one has both. The negative flips this upside down, making it 1/3. The 1/2 takes it from 9 to 3. Again, not the main idea. As long as you're getting the idea of this being the what power function, that's the key piece here that you need to have down. But the more of this extra stuff that you get, the easier next year will be. Also, the easier the state test will be for you guys coming up in a couple months. All right, 13. We had mentioned that anytime there isn't a base written, it's base 10. So 13 is literally just 10 to what power? Gives me 1,000. Well, 10 times 10 times 10 times, actually that's it. There's 3 10s because I've got 3 zeros here, so that's 10 to the 3rd power. Whereas this one has 1, 2, 3, 4, 5 zeros, so that's going to be 10 to the 5th power. Literally every time you multiply by a 10, you get another 0 in your number. So if it's 1 followed by a bunch of zeros, it's 10 to however many zeros there are. If it's written like this as a 10 to an exponent, it's even easier. 10 to the 8th power. Literally 10 to what power makes 10 to the 8th power? I just said the answer. The answer is 8. And then here, sorry about that. This one, again, it's going from log base 10 to 1/10. That's the reciprocal. That means -1. The -1 flips it upside down. Okay, and now we have some natural logs. If we had been doing this all together, I would probably have skipped the natural logs right now. But because I was letting you guys watch a video of the Math 3 lesson from a previous time, you guys got to see natural logs. Hopefully they made sense. The idea is a natural log literally just means log base e of whatever's inside. So here it's e to the 4th. And so even just reading this out loud, log base e of e to the 4th is what power of e makes e to the 4th power? The answer is just 4. And then we've already said for 18, anytime we have a log of 1 our answer is 0, whether it's natural log or any other base. For 19, the natural log of 1 over e to the 5th power. Okay, so again, natural log means log base e. E to what power makes 1 over e to the 5th power? Well, it's going to be to the 5th power, but negative, that's what makes it flipped upside down. 1 over my answer. It was raised to the negative 5th power. And here, natural log of the 4th root of e, that 4th root is a 1 over 4 exponent. So again, in the traditional Math 3 classes, this year, we did a whole unit on square roots and cube roots and 4th roots before we got to logs. The trick is that next year, I believe the curriculum kind of switches the order. You see these logs before you get to the real lessons on roots. And I think some of that's because the students that are taking Math 2 this year are getting more of that right now. And so you guys, again, a little bit out of order. So we're figuring it out. Please ask if you have questions when I'm back, if you're not sure. But again, that 4th root literally means e to the 1/4 power. And so when it asks me the natural log or log base e of e to the 1 over 4 power, e to what power gives me e to the 1/4 power? It's the 1/4 power. Again, I'm saying the answer as I'm reading the question. Now, these we're asking you to approximate, essentially say, okay, log base 2 could be 2, like 2 to a power. I could do 2 to the 1st power is 2, 2 squared is 4, 2 to the 3rd power is 8, 2 to the 4th power is 16, 2 to the 5th power is 32. 30 is in between 16 and 32. And these were the 1st power, 2nd power, 3rd power, 4th power, 5th power. So 30 is in between 16 and 32, which means the answer here is between 4 and 5. Excuse me, up until now, we've been only dealing with really whole number exponents. Here we start to see some decimal exponents. It's impossible for you to figure out exactly what those decimals would be without a calculator. But we can say what 2 numbers it would be between using this kind of approximation, saying, okay, I can raise 2 to the 4th power and get 16, that's too small, but 2 to the 5th power is 32, that's too big. So my answer here for 2 to what power makes 30 is between 4 and 5. So then the next one, 7 to the 1st power is 7. 7 squared is 49. So that's between the 1st and 2nd power. So between 1 and 2. Here, 4, log base 4 of 100. Well, let's see here, 4 to the 1st power is 4. 4 to the 2nd power is 16. 4 to the 3rd power is 64. And then here, I would need a calculator possibly to do this if I didn't know all of the different powers of 2 so well, because we use them so much in Math 3 and in computers in general and all kinds of other places. So here, log base 4 of 100. 4 to what power makes 100? Okay, 4 to the 1st power, 2nd power, 3rd power. 4th power would be 64 times 4 again, and that's 256. And 100 is in between these two. So then this answer is between 3 and 4. 1, 2, 3, 4. Between 3 and 4. Log base 3 of 75 then. Okay, 3 to the 1st power. We were just doing these earlier, like the first problem. 1st power, 2nd power, 3rd, oops, too far. 3rd power. Make sure I'm doing that right. Yeah, 3rd power. 4th power. Okay, right there, in between 3 and 4. All right, and then the last few problems, you saw an, oh, sorry, almost missed this one. Okay, this one, 10 to the 1st power is 10. 10 squared is 100. 10 cubed is 1,000. Okay, that's still less than 7,500. 10 to the fourth power, that would have 4 zeros. That's bigger than this. So again, I'm between 3 and 4. 23, 24, and 25 are all between 3 and 4. All right, and then the last set here for this worksheet. Find the y-intercept for the following functions. Remember, to find the y-intercept, we plug in 0 for x. So that means y is equal to log base 3 of 0 plus 9 minus 1. So 0 plus 9 is 9. Log base 3 of 9 minus 1. Notice how the minus 1 is not inside the log. So that means I'm going to do log base 3 of 9 first. Log base 3 of 9, 3 to what power makes 9? That's 2. 2 minus 1 is 1. So the y-intercept is either 1, or you could say it is 0, 1, that point. Should be using different colors here to keep stuff separated a little bit more. The next one, make the x 0 again for the y-intercept. Y is equal to log base 2 of 0 plus 16 plus 3. Do the 0 plus 16, log base 2 of 16 plus 3. 2 to what power makes 16? 2, 4, 8, 16. That's 2 to the fourth power. So 4 plus 3 is 7. So I have the point 0, 7, right? I put in 0, I got out 7. That's my y-intercept. And then this one's a little tricky. You've got to use that little one of those special cases that we've talked about. Y is equal to log. They don't give us the base, but we know it's 10. But it actually doesn't matter because we're going to do 0 plus 1 plus 4. And we've said a couple times now, log base anything of 1 is always going to be 0 because anything to the 0 power is 1. So we just get 4. And again, we put in 0, got out 4. That's our point. Now down here, I told you guys not to do this, but it's actually really handy. It's a great application connection to your science classes. The pH scale is based on a log scale. And so literally when you're looking at this, these values are all to a power, and that power is more or less what ends up determining the pH of different substances here. We won't go into it in detail. Again, you'd probably end up doing some of this, hopefully, in one of your science classes at some point. If you have questions about it when I'm back, though, I'd be happy to go over it with you guys because it is one of the direct links for what we're doing to the real world as well. I often make this extra credit in my Math 3 classes, and you'll probably get more of it next year in the new curriculum with Math 3. All right, so that's it for the 9.2 worksheet. Now let's look at the 6.5 one. Finding the inverses of each function. Hopefully this made sense to you. You saw a couple videos. We'd started to talk about it together when I was still there. But the idea for each of these is that you're swapping the x's and y's and then solving for y. And that typically involves you rewriting this in a way to switch it from being logs to exponents, or on the second page, the back page, from exponents to logs. So like here, I switch the x and y. So x is equal to log base 4 of y plus 10. That plus 10 is not inside the log, so I'm going to get the log by itself. I'm going to subtract 10 from both sides. Minus 10, minus 10. X minus 10 is equal to log base 4 of y. So now the 4 comes down, 4 to the x minus 10 power. And that whole thing is supposed to equal to y, whatever was inside the log. So y is 4 to the x minus 10 power. There's my inverse equation for that. On the other side here, we've already got this set up with just the log by itself. So I swap the x and y. X is equal to log base 1/2 4 to the x power, to the y power. Now this one ends up being a little interesting. When we switch this, the 1/2 comes down, 1/2 to the x power is equal to 4 to the y power. Now, I don't know if the videos, I don't remember if the videos went into enough detail for you to finish doing one like this. In essence, there's a couple ways that you could try to work this guy out. If you got this far, it's going to be good enough for now. We would really want to get that y by itself. And that really actually requires you using a different rule here at the very beginning and essentially taking this y and bringing it down in front and figuring out, okay, what power of 1/2 makes 4. So for now, if you just did the switch, that's going to be enough. Once I'm back, we'll talk a little bit more about how this whole thing works. I don't think that comes up very often on this worksheet, but I think we had that same kind of thing happen when I was there in class as well, where it's just a little beyond where we're trying to go in this foundations class. So this one, a little bit easier. Log's already by itself. To switch the x and the y, x is equal to log base 2 of y squared. So then the 2 comes down, 2 to the x power is equal to y squared. Again, this one's pretty good, except we can really finish that one without too much trouble by taking the square root. We've done that before, solving for a variable that's to a second power. Take the square root of both sides. Get y is equal to the square root of 2 to the x power. That would be our inverse function for that guy. Number 4, we're going to switch the x's and y's. X is equal to the negative log base 3 of y. So now the 3 comes down, or actually, first, the log isn't actually by itself yet. We need to get rid of this negative. So to do that, I'm going to multiply both sides by a -1. If I multiply both sides by a -1, this becomes positive, this becomes negative. And now the log here is by itself. It doesn't have that negative out in front. So I can bring the 3 down. 3 to the negative x power is equal to what was inside the log, which was just y. Y equals 3 to the negative x power. For number 5, I need to get that log by itself. So I'm going to divide both sides by 8. Y over 8 is equal to log base 4 of x. Now, log of the base, log base something of whatever is by itself. So I can bring the base down. Oops, wait a second, back up. We didn't switch the x's and y's. Again, I'll try not to forget that. Hopefully you guys will do the same. Really, we could just do that right now, actually. We don't even need to undo anything. Just switch the x's and y's right now so that we're actually ending up with the inverse. X and y. So now when I actually work this out, I'll have y by itself. I'll bring the 4 down. This becomes my exponent. X over 8 is equal to y. Y equals 4 to the x over 8 power. This next one, the trick with this one is just remembering that this is a log base 10. As long as you remember that, we can switch the x and y. X equals log base 10 of -2x. 10 comes down, 10 to the x power equals, sorry, I did the same thing here. Should be a y. Let me switch those. Equals -2y. And again, I'm catching that I'm making those mistakes because as I'm going through, I'm trying to solve for y. If I had not noticed that just a moment ago, I wouldn't have had a y to solve for. But here, now I have a y. I can finish solving for that by dividing both sides by -2. And that's my answer. Negative 2's cancel out, reduce to just 1, and I've got y is equal to 10 to the x power divided by negative 2. So again, notice how all these logs, their inverses are all something to a power with the variable up in that power. Number 7, switch the x and y. X is equal to log base 5 of y minus 7. Bring the 5 down, 5 to the x power equal to y minus 7. I can add 7 to both sides. Y is equal to 5 to the x power plus 7. There we go, that's my answer. Number 8, switch the x's and y's. X is equal to log base 6 of y minus 9. Six comes down, 6 to the x power is equal to y minus 9. Here, I do have one extra step here. Now, actually, looking at that one again, this one's not the greatest problem. They did not put that in parentheses. I was kind of assuming it was. Let's back up though, because if I look down here at number 10, they obviously put this one in parentheses. So looking at that one again, I don't think that's supposed to be in parentheses there. So that means I actually have a step to do to get the log base 6 of y by itself. I need to add that 9 to both sides first. So let's do that. Plus 9 plus 9. X plus 9 is equal to log base 6 of y. Now I'd bring the 6 down. 6 to the x plus 9 power is equal to y, and I'd be done at that point. Number 9, this is by itself. There's nothing else besides the log and what's inside it on this side, so the 6 comes down. And again, here, normally I should be switching the x's and y's. A lot of the time, though, you guys are going to get to the point where you're not going to have to do that step, or at least not write it out of saying, okay, it's x is equal to log base 6 of 2y. If you get to the point where you know that is the first step, and you can go ahead and switch straight to 6 to the x power is equal to 2y, you are welcome to do that if you skip that middle step of actually switching the x's and y's. But if it helps you, keep doing it. So now last step for this one, divide both sides by 2. Y is equal to 6 to the x power divided by 2. That didn't work. Let's get that 2 on there. 2. There we go. The last of this kind, we've got this guy. This is, again, we can easily see it. This is all one piece. Switch the x's and y's. Y plus 8 in here. 2 comes down to the x power is equal to y plus 8. Subtract 8 from both sides. Y is equal to 2 to the x power minus 8. So again, notice how this minus 8 is not in the exponent, whereas this plus 9 was, because again, the parentheses here are changing what order things happen in the original equation. And so that's going to change what order things happen in the inverse equation as well. All right, so now coming down here, number 11. Number 11, y is equal to negative 6 to the x power divided by 4. Now we're going to be going backwards. It's the exact same thing we were just doing, but instead of writing the log as an exponent, we're going to write the exponent as a log. So first step, switch the x and y. X is equal to negative 6 to the y power over 4. That looks like a y. Let's make that more of a 4. There we go. Now I need to get this, the number to a power by itself. So I'm going to go ahead and multiply both sides by negative 4 to undo this dividing by a negative 4. So times negative 4 times negative 4. So I've got negative 4x is equal to 6 to the y power. right? Because the negatives here would cancel out, the 4s cancel. And so now I can switch this. The 6 comes down and becomes my base of my log. Log base 6 of whatever it was equal to, so of negative 4x, is equal to my exponent, y. I know you, sorry, I know you saw a lot of those, or a couple of those examples last week, but again, that's something that I hadn't really talked with you guys about before I was gone. So the hope is that that's starting to make sense. Let's do a few more of those. All right, this next number 12 is rough. If you got number 11, great. That's the main point of what I'm wanting you guys to pick up on. Number 12 has some strange stuff in it, so we'll do the best we can here. The trick here is seeing this 1 over and realizing, oh, I can make that a negative exponent. I can rewrite this. Y is equal to 2 to the negative 1 plus x, which then makes this so much easier. I can swap the x's and y's. X is equal to 2 to the negative 1 plus x. So then I can switch this to logarithmic form. Negative 1 plus x is equal to log base 2. Oh, and I did it again. I've got 2 x's, no y's. Let's fix that right now. Again, if any of you are shouting out that I missed that, I apologize that you're not getting the extra credit for catching my mistake right now. So we'd swap this. This is the y right there. Actually, I should have erased the red x. That should have still been an x there. There we go. So this came over here, which makes much more sense now. So that we're getting the y by itself on this side. Whatever was equal to over here, that's what's inside the log now. So log base 2 of x. Now I can get rid of the negative, multiply both sides by a -1 or divide by a -1, either one's fine. We get 1 plus y is equal to negative log base 2 of x. Then I can subtract 1 from both sides to get y by itself. So if I subtract 1 from both sides, I get my final answer. Y is equal to the negative log base 2 of x minus 1. And on to 13. This one's a little nicer. Switch the x and y. X is equal to 2 to the y over 5. Bring the 2 down. Log base 2 of y over 5, or equals y over 5 here. That goes on the other side. And then inside the log is going to be what we were equal to. Now this one, I've got to get y by itself. I've got one extra step here. I need to multiply both sides by 5 to get rid of that. So I have y is equal to, really, we typically put the 5 out in front, 5 log base 2 of x. Now, there are more things that we can do with these once we learn all the different properties of logs. For now, though, we're focusing on just what is a log and its relationship with the inverse with exponents. Later on, we can talk about what we could do with this 5 to kind of condense this log as well. But for now, this is good enough. Next one, number 14. I'm going to get the 2 to the x power by itself, so subtracting 10 from both sides. Y minus 10 is equal to 2 to the x power. Again, I should maybe have swapped the x and y at the very beginning, but as long as you do it at some point here, so that you're solving for y with the inverse, where x and y have been switched, you'll be okay. So let's switch them right now. X minus 10 is equal to 2 to the y power. I can bring the 2 down, make it into my log base 2 of x minus 10. Right, this over here inside the log, is equal to what the old exponent was. And I'm done. Y equals log base 2 of x minus 10. Next one, same idea. Let's swap the x and y. X is equal to 3 to the y over 4. Bring the 3 down, log base 3 of x is equal to y over 4. And again, this time the y is not by itself, so I've got that extra step of multiplying both sides by 4. Again, that 4 then goes in front of the log. Y is equal to 4 log base 3 of x. 16. I need to get e to the x by itself first. Let's go ahead and swap the variables right now. X is equal to negative e to the y power over 4. I would go ahead and get rid of that negative 4 right now. So times negative 4 times negative 4. 4's cancel out, negatives cancel out, become positives. Left with negative 4x is equal to e to the y. The e comes down. Now you can write this as log base e, but next year you really want to get used to thinking of that as the natural log. That's what natural log is, just a shortcut way of writing log base e. So let's go ahead and do that now. Natural log of negative 4x. You don't even have to write the e because that's what the natural log means. Again, if you wrote log base e of negative 4x, it's fine. But this is a little better. Natural log of negative 4x is equal to y. And here y is equal to 6 to the x power over 4. Get rid of that 4, multiply both sides by 4. And let's swap the x's and y's right now. So this is 4x equal to 6 to the y power. 6 comes down. Log base 6 of 4x is equal to y. And we're done. $18, I can swap the x and y right now. X is equal to 6 to the y power minus 5, but I need to get that 6 to the y power by itself before I can switch to log form. So I'm going to add 5 to both sides. Get x plus 5 is equal to 6 to the y power. 6 comes down. Log base 6 here of x plus 5 is equal to y. Again, whatever the exponent was is now what it's equal to. And last couple here, almost identical here. X and y switches. X is equal to 4 to the y over 4. Bring the 4 down, log base 4 of x equal to y divided by 4. And then we can multiply both sides by 4. Fours cancel. Y is equal to 4 log base 4 of x. I haven't been mentioning it enough, but make sure your base is down nice and low, that it looks like the base and not log 4x altogether, or else someone may think that it's log base 10. Try to make that a really obvious base. And then this one you could probably guess just off of the last one. There's only one little change, but be careful because we've got a 4 and a 4 here and a 4 and a 6 here. Make sure you know which 4 that 6 replaced. So if we actually work this one all the way out, swap the x's and y's. X is equal to 6 to the y over 4. 6 comes down, log base 6. So again, that 6 was the base. The x goes inside, and it's equal to y divided by 4. Can multiply both sides by 4 here. Y is equal to 4 log base 6 of x. All right, so that's it for the 2 worksheets from Thursday. Hopefully, again, the videos made sense, but now you've had a chance to check your work. Again, some of you may have had that all down already. We're perfect. Thank you for bearing with us as we went through each of those. Others, that may have still been really hard. And so hopefully as you saw the examples worked out, if it makes more sense, when I am back, feel free to ask any questions you have. You can also send me emails right now or Google chat message or Google Classroom messages, anything like that would be fine too. On Friday, you should have gotten this worksheet, which is essentially a redo of the review worksheet that we ended last semester with. So it's got just a bunch of stuff from last semester. You can have the rest of the time today to finish anything you didn't have here, but I'm just going to point out a couple of things. So you're graphing absolute value graph here. I should see a V-shaped graph, straight line for number 2, quadratic for number 3, writing the equation of a quadratic for number 4, writing the equation of an absolute value for number 5, and then here domain and range. Remember, domain is the x's left to right, range is the y's bottom to top. Notice the solid dots at the 2 endpoints, and again, assume that any point on the line is included. So like we make it all the way down here to +1, -3 right there. On the second page, same idea here, but you've got an open circle right there. Watch out for that one. That's going to mess with your domain and range. Here, domain range, this one continues on. It doesn't have endpoints for that absolute value. So list those. Here, you did not probably have enough room to write your work here. Again, hopefully you're using a blank piece of paper to do your work here. Solve each equation, this one with the quadratic formula. These with factoring, what multiplies to -42 and adds to 1. This one, again, just what do they have in common? Solve them. So your final answer, n equals 2 numbers. Here, a equals 2 numbers. 12, simplifying, so you're combining 4 times 4. We have a y to the first power, y to the 4th power, x to the -2, x to the -4. Make sure your final answer, any negative exponents get rewritten as numbers down on the bottom in the denominator of the fraction. The simplifying expressions, the first couple are already factored for you. Just look for those that show up on the top and the bottom. Cancel those factors out. 15, 16, 17, well, 17 and 18, not really. 15, 16, and 19, you're going to have to factor. Oh, and it looks like you lucked out. None of those were trinomials when I made this worksheet quickly. And so do the best you can with those, but it's literally most of those are factoring by greatest common factor, seeing what factors you have on the top and the bottom. And then the last one, well, sorry, the last few, we've got another graphing one. This one, remember there was a asymptote, 2 asymptotes that we don't go by. You could plug in numbers. We tried several of these. Do the best you can on this one. And then we've got a couple solving problems of figuring, okay, what number would work for both of these? It says by substitution, you could graph them. You could set them equal to each other and solve. That's what we did a lot of last semester. So do the best you can with those. Take the next, whatever time is left over in class here to try to finish any of the rest of this. Finish it as homework if you need to. And then again, the hope is that I'll be back tomorrow if all goes well. I hope you're all doing well, and I look forward to seeing you again. Again, thank you for putting up with this for the last 4 days or so while I've been out. Miss you guys. I hope to see you again tomorrow. Thanks.